I want you to think about your own reading habits for just a second. Like, really picture it. Imagine you are trying to understand something deeply complex, and you've got maybe three different heavy books propped open on your desk.
Oh, yeah, and usually a completely unmanageable browser window.
Exactly. You have at least a dozen browser tabs clustered so tightly at the top of your screen that you can't even read the titles anymore. You just see those tiny little icons.
Right.
Plus, there's probably a stack of printed PDFs next to your keyboard, completely covered in like 3 different colors of highlighter. And you're just sitting there rubbing your temples, feeling completely frustrated.
It's a very familiar feeling for a lot of people.
Yeah, you're trying to connect the dots between all these different sources. And have you ever felt that way? Like, your brain simply cannot hold all the pieces of the puzzle together at the same time.
Because it really can't. Human working memory just isn't built for that.
Right. Well, today we are going to give you a pass. That feeling of overwhelm, it isn't actually a failure of your brain. It is a failure of, frankly, 15th century technology that we are all still blindly using today.
I mean, it sounds like a massive claim, right? Looking back at hundreds of years of publishing history and just calling it a flat-out failure.
It really does. But to explain why that friction exists, our deep dive today is focused on this really fascinating architectural spec called the Hypercodex.
Yeah, written by Elias Tunis. It's part essay, part technical, open challenge.
Exactly. And our mission today is to unpack this radical new way of structuring human knowledge, a way that completely abandons the traditional book or article format to actually, match how our minds naturally process the world.
And the core premise of the essay, it really hits you the moment you hear it. Knowledge is naturally a graph, but publication flattens it into a line.
A graph meaning like a web, right?
Yeah, exactly. If you think about how concepts actually exist out in the real world, they are a sprawling, interconnected network. They connect through historical causes, through abstract analogies, and through complex hierarchies.
The essay gives this fantastic, really tangible example of this network.
Yep.
Let's say you want to genuinely understand Charles Darwin's theory of natural selection.
Right, which is a massive topic.
Huge.
Yeah.
And you cannot just look at it in isolation. Natural selection connects directly to the mathematics of game theory.
And then game theory connects to human institutional design.
Exactly. Which in turn connects to something incredibly modern like AI alignment. True understanding means knowing all those dependencies. You have to be able to hold your place in that three-dimensional web.
But every single traditional format we use to publish information actively destroys that three-dimensional web.
It just crushes it.
It does. The author actually calls this destruction the serialization tax. Think about what a book does. It imposes a rigid, linear, page-by-page order.
Right, chapter 1, chapter 2, chapter 3.
Exactly. Or an academic paper, which imposes a highly structured sequential argument format. A blog post forces a chronological timeline based purely on when something was written.
Just a feed of dates.
Yeah. Each of these formats takes that beautiful, sprawling web of knowledge and forces it through a tiny, one-dimensional linear stream. And then we have the audacity to ask the reader to do the exhausting cognitive work of reconstructing that original multidimensional graph inside their own head.
Okay, let's unpack this because I want to make sure we really visualize what's being lost here. It's like taking a fully built, incredibly intricate Lego castle.
Okay, I like that analogy.
But instead of showing you the castle, I break it down into a single file line of loose bricks. I hand you the bricks one by one continuously, and I say, here, just hold on to these and rebuild the entire castle in your working memory as I hand you these bricks.
Which is impossible.
It is completely absurd when you put it that way. No wonder we highlight things and immediately forget them.
Exactly. The cognitive load of holding that mental blueprint is exactly why most people forget what they read. And what's fascinating here is that the brightest minds in computing saw this flaw a very long time ago.
Wait, really? How long ago?
The essay points out that Vannevar Bush recognized this exact problem back in 1945.
Wow, 1945.
Yeah. He wrote that the human mind naturally, quote, operates by association, skipping from one idea to the next. But our filing cabinets and our library catalogs, they force us into alphabetical or sequential access.
Because they have to, physically.
Right. Bush even proposed a theoretical machine called the Memex to let people finally follow associative trails. And then later, in the 1960s, Ted Nelson envisioned a project called Xanadu.
Oh, I've heard of Xanadu.
Yeah, it relied on complex bidirectional links to maintain those conceptual connections.
But you would think, the modern internet would have solved this, right? Like we have hyperlinks.
You would think so.
But the author points out that the modern web, just reverted to the old medieval models. We just took paper PDFs and put them on glowing screens. We took linear diary entries and called them date-sorted blogs.
We digitized the linear constraint instead of breaking it.
We totally did.
So the question that naturally follows is, if brilliant people knew about this fundamental flaw in 1945, why are we only trying to build something like the Hypercodex today? Why did it take 80 years?
Yeah, what changed?
The answer comes down to pure economics. The constraints of writing have fundamentally shifted in just the last few years.
Okay, how so?
Well, for 5 centuries, the absolute bottleneck of human knowledge was production. Writing a comprehensive book takes years of agonizing human labor.
And printing it takes immense capital.
Exactly. Distributing it takes massive physical logistics.
So the linear book was essentially the most highly optimized way to push a polished idea through that massive, slow-moving bottleneck. You had to put all your effort into one perfectly polished, static artifact because you only got one shot to print it.
Precisely. You couldn't just casually update a physical book. But then, large language models entered the picture.
Ah, AI.
Yeah. The marginal cost of producing a well-structured, thoroughly researched 3,000-word essay dropped from weeks of grueling labor to mere hours.
Okay, wait, let me just pause you there because my alarm bells are ringing a little bit.
Sure, go ahead.
Is the author suggesting that AI is just going to write everything for us now? Because if that's the premise, that sounds like a recipe for a terrifying tsunami of very confident, very average, completely soulless content.
That is a totally valid fear, but the author is incredibly careful to draw a line there.
Okay, good.
The human still completely owns the thesis. The human evaluates the claims, makes the crucial editorial judgments, and verifies the output. The machine is strictly brought in to handle the mechanical labor.
Meaning what exactly?
It drafts the connective prose, it formats the data structures, it generates the comparative tables, and it cross-checks internal consistency.
Oh, I see. So the human is the architect holding the blueprint, and the AI is the bricklayer actually stacking materials.
That's a perfect way to put it. And that division of labor means a phase transition has finally occurred in human history.
Because production isn't the problem anymore.
Right. The new constraints are no longer about physically producing the text. The new bottlenecks are curation, meaning in a sea of infinite text, is this specific thing even worth reading?
Yeah, that's the big question today.
And architecture. How does this piece of isolated information actually connect to the broader web of human knowledge?
The essay actually points out that AI doesn't just help write. It solves a massive problem with that architecture. Historically, keeping a dense web of cross-references perfectly accurate was basically impossible.
It totally exceeded human working memory.
Yeah, if you updated a concept in Chapter 2, you might easily forget to update the corresponding argument in Chapter 9. Links would break. But modern AI doesn't just read words. It mathematically maps the meaning of those words. So it can continuously scan your entire body of work and spot if you just contradicted a claim you made 3 months ago. It maintains the logic of the entire web.
So the technology to maintain the edges between ideas is finally here. Hyperlinks are a solved technology. AI consistency checking is a solved technology. The unsolved problem is how we actually design the structure for the reader.
Okay, so if we agree that the traditional book is broken and AI gives us the cheap labor to build something much better, what are we actually building? What does a hypercodex actually look like? Are we just making slightly fancier Wikipedia pages?
No, it looks fundamentally different from anything we use today. The essay outlines a new architecture built on a few core shifts.
Okay, what's the first one?
The first shift is the move to self-contained nodes. The author brings up Andy Matuszek's concept of evergreen nodes here.
Oh, evergreen nodes. I've heard of that.
The rule is that every single concept or argument in the Hypercodex must be complete on its own. You don't have to read Chapter 1 to understand Chapter 4.
Oh, wow.
Yeah, you can drop into the network at any random point, and you leave with a complete, logically sound argument.
You know, the beauty of that constraint is that every single node has to rederive its premises from scratch. You aren't allowed to use lazy phrases like, as I mentioned previously.
Right, which forces the writing to be incredibly dense, highly compressed, and deeply respectful of the reader's time.
I love that. So how do these nodes connect?
Well, to connect those dense nodes, the architecture relies on explicit structural connections. And we aren't talking about dropping a generic blue hyperlink to a random Wikipedia page just because a word matches.
Like what we see everywhere now.
Right. These links explicitly state their relationship to the text. The link itself tells you, click here to see how this same method applies to a completely different domain, or click here to see the raw statistical evidence for the claim I just made.
Oh, so the link tells you why you should click it?
Exactly. These cross-links are the scaffolding. They allow the reader to rebuild the knowledge graph based on their own curiosity rather than the author's predetermined sequence.
Here's where it gets really interesting, though. Because if you have all these dense nodes and thousands of structural links, it sounds super overwhelming.
It does.
But the author introduces a concept called graduated disclosure. The surface of the text you initially look at is incredibly clean and scannable.
Right. You're not hit with a wall of text.
Yeah, if you just want the core thesis of an argument, you can get it in 10 seconds. But if you want to understand the underlying mechanism, you click, and the text expands to give you a 3-minute version. If you want the deep historical evidence, you expand it again.
It's all about controlling depth.
It reminds me of opening a map in a massive open-world video game. When you first open the map, you just see the broad continent and major cities.
Right. You don't see every single tree or merchant.
Exactly. You don't see every street sign all at once because that would paralyze you with information overload. You only zoom in to the insanely detailed street level when your character actually needs to go there.
The video game map is the perfect way to visualize it, and historically we actually attempted this kind of layered depth.
Really? Before computers?
Oh, yeah. The essay notes a fascinating parallel with the medieval glossa ordinaria.
Oh, what now?
The glossa ordinaria. Before the printing press standardized everything, medieval scholars would take a central text, say, a piece of scripture, and surround it with concentric layers of commentary, structural summaries, and cross-references.
All on the same physical page.
All on the same page.
Yeah.
You could read just the center, or you could wander through the margins. The Hypercodex basically takes that medieval instinct for layered knowledge and scales it up to govern the architecture of an entire digital system.
That is so cool. And the author points to Goran Branwen's site as the closest current example we have of this, right?
Yes. Goran's site is an incredible repository of self-contained, densely linked, heavily layered long-form essays.
And it's very different from Wikipedia.
Contrasting a site like Goran's with Wikipedia is really illustrative. Wikipedia is essentially a hypercodex optimized purely for breadth and absolute neutrality.
Right, which is great for finding out when someone was born.
Exactly. It is fantastic if you want a factual answer to the question, what is this thing? But because of its neutral, consensus-driven editorial model, Wikipedia is structurally incapable of answering deeper questions.
Like what?
Like, why does this matter? Or what are the hidden implications of this? Answering those questions requires a unified, opinionated, analytical perspective. That is the kind of depth the Hypercodex aims to capture.
But you know, even a deeply layered site like Goran's is missing one crucial element. And this is the part of the essay that completely blew my mind.
Yeah, this is the really radical part.
The missing layer is something the author calls dialectical provenance.
Which is a fancy term, but it raises an important question about the hidden life cycle of an argument.
Right.
Currently, when we read a brilliant essay, we are only seeing the surviving output. We are looking at the final, highly polished, stress-tested idea.
Like the tip of the iceberg.
Exactly. What is entirely invisible to us are all the discarded counterarguments, the failed alternative framings, and the intense questioning the author wrestled with for weeks to arrive at that conclusion. All that intellectual sweat is hidden behind the curtain.
And the essay argues this creates a massive asymmetry of disagreement. Let's say you're reading a piece, and your brain immediately flags a point you disagree with.
Happens all the time.
Yeah. You, as the reader, now have to sit there, stop reading, and independently rederive the exact counter-arguments that the author probably already spent 3 weeks working through and defeating.
Yes.
You might even get frustrated and stop reading entirely because you think the author missed an obvious flaw, when in reality, they just didn't include their defense in the final draft.
It's a tremendous waste of collective human cognitive effort. Past thinkers recognized this and tried to map out the invisible debate.
Oh, like who?
Well, in 1958, a philosopher named Stephen Toulmin created a formal model for mapping arguments and evidence.
Okay.
And then in the 1970s, Horst Riddle introduced issue-based information systems, or IBIS, to systematically map claims and counterclaims. But every single one of these noble attempts failed.
Let me guess. They failed because manually mapping out every single argument, counter-argument, and piece of supporting evidence alongside your actual writing is a complete logistical nightmare.
It absolutely is. The manual data entry bottleneck was fatal. Stopping your creative flow to meticulously categorize your own counterarguments into a database is just too exhausting for any human being to sustain long term.
I hear that, but let me put myself in the shoes of a busy listener for a second.
Sure.
If I'm already overwhelmed by the amount of content out there, why on earth would I want to read an author's discarded arguments? Doesn't adding all that extra debate just add more noise to the serialization tax we talked about earlier?
What's fascinating here is how the author envisions capturing this. The Hypercodex isn't about publishing raw, unfiltered transcripts of your messy brainstorming sessions.
Okay, because that would be awful to read.
That would be terrible compression.
Right.
It's about highly curated distillations. Think about how we write with AI today. You might argue with an AI assistant like Claude or ChatGPT for an hour to refine a single thesis.
Yeah, throwing ideas back and forth.
Right. You throw counterarguments at it, it pushes back, you refine your point. Normally, you take the final polished paragraph and throw their entire hour of rich adversarial chat logs straight in the trash.
Oh. So the Hypercodex says, keep the chat logs, feed that conversational exhaust back into the AI, and let the AI automatically categorize the hardest counterarguments you debated, attaching them to the final text as hidden clickable layers.
Precisely that. Imagine reading an article, and underneath a highly controversial claim, you can click a subtle toggle that says, here is the strongest counterargument to this point, and here is exactly why the author believes it fails.
Oh, I love that.
Or even better, a toggle that says, here is the specific evidence that would actually force the author to change their mind on this topic.
So what does this all mean for the relationship between the writer and the reader? It builds immense trust. It saves the skeptical reader so much time because you're showing your math. You are proving you didn't just ignore the counterarguments, you already defeated them.
It fundamentally changes the act of reading from passively receiving a lecture to actively exploring a hardened intellectual fortress.
Okay, I am completely sold on the concept, but realistically, I have a major logistical concern.
Let's hear it.
If I am an author, and I am hosting a dynamically generating, infinitely layered argument that anticipates counterarguments and reformats itself for every single person who clicks a link on my site, my cloud computing bill is going to bankrupt me by Tuesday.
Oh, easily.
How do you practically build and host this without eating massive server farms?
The hosting costs would absolutely destroy you if you tried to run this as a live, real-time application. But the author proposes a brilliant computational workaround.
Which is,
The secret sauce is that the AI acts as a compiler during the build step, not as a runtime chatbot.
oh, I get it. So just like exporting a massive complex video editing project into a simple MP4 file, you do all the heavy processing up front.
Exactly that mechanism. When the author is ready to publish, they hit compile, and the AI goes to work entirely on the back end. It pre-computes everything.
Everything.
Yeah, it takes an explanation of a concept that appears in multiple places and seamlessly embeds it wherever it's needed, using strictly the author's own verified body of work. It doesn't hallucinate a summary from the open internet. It relies entirely on the author's established premises.
That's a huge relief.
And it also pre-computes all those what-ifs, the objections and domain applications based on the dialectical chat logs we just discussed.
And it does all this heavy lifting exactly once. It might take your computer hours to run the build, churning through all those connections, but the output it generates is incredibly cheap. It just spits out entirely static, lightweight web pages.
Right. Because the output is just simple static text files, you can host this incredibly rich, multidimensional knowledge graph on a standard $5 a month web host.
That is wild.
There is no AI running in the background when the reader visits the site. There are 0 API costs incurred per reader.
Which completely flips the problem we are seeing with modern AI tools right now. Like the big trend right now is RAG retrieval augmented generation.
Yes, the chatbot interface.
That's where you point a chatbot at a huge database of documents and you just type questions into a chat window.
The essay reserves a very sharp critique for modern RGREG systems. When you use RAG, it goes into a beautifully constructed multidimensional knowledge graph, retrieves the requested information, and then what does it do?
It flattens it.
It flattens it right back into a linear chat thread.
It creates a brand new serialization tax. We just invented the most advanced technology in human history, only to force it to spit out a single file line of Lego bricks all over again.
Exactly. RA takes the author's carefully constructed architectural map and violently collapses it into a paragraph-by-paragraph sequence. It destroys the structure just as effectively as a traditional printed book does.
So the Hypercodex completely upends this dynamic.
Yeah.
Instead of the author paying to provide a live chatbot that destroys their own work, the author simply provides the beautifully structured, pre-rendered static graph.
Yes.
And if a reader comes along and has a genuinely novel question,
Hmm.
something the compiler didn't anticipate, the reader simply brings their own personal AI assistant to navigate the author's graph.
It is an incredibly elegant division of labor. The author provides the beautifully structured knowledge, and the reader provides their own compute power to explore it.
Win-win.
The graph remains perfectly intact, and the reader's AI can traverse the author's causal maps instead of destroying them to generate a summary.
Man, this whole deep dive just makes you realize how entirely blind we have been to the formats we use every single day. The essay points out something so obvious once you hear it.
About the physical constraints.
Yeah. Nonfiction books are typically 80,000 words simply because traditional publishers price physical books by their shipping weight.
It's all about the supply chain.
Academic papers are 8,000 words because journals inherited strict evaluation criteria based on the physical constraints of a printed magazine. Blog posts are sorted chronologically simply because that was the default setting programmed into WordPress 2 decades ago.
It's kind of funny when you lay it all out.
We have treated the format of knowledge as a given, like it's an immutable law of physics. But it's not. It's a design variable. The Hypercodex is essentially a blueprint to finally break us free from 15th century manufacturing defects.
And it is vital to remember that Elias Kunis published this essay not as a finished product, but as an open spec, a challenge.
Right, he's basically daring people to build it.
Exactly. The individual pieces already exist in the world today. We have the AI models, we have the static site generators, we have the tools to map semantic meaning, but no one has actually wired them all together yet to enforce this specific revolutionary architectural contract.
So if you are a developer out there listening right now, the gauntlet has been formally thrown down. The author is actively looking for people to build this and change how we interact with information.
You know, if we connect this to the bigger picture, I think there's a profound psychological implication here to leave you with.
Oh, what's that?
Think about it. For your entire life, the way you structure your own internal thoughts has been subconsciously dictated by the linear media you consume.
Oh, wow.
You have been trained to think in straight lines because you have only ever read in straight lines. If a hypercodex actually gets built and becomes the new normal, how might your own internal thinking process change when you are finally allowed to consume and therefore learn to think in sprawling, multidimensional graphs?
It's wild to think about what our brains are actually capable of. We've been trying to force a sprawling, beautiful network of ideas into a single file line of Lego bricks for 500 years. Maybe it's finally time we just build the castle.